Hello, class. Okay. Good morning, good afternoon, good evening. Okay, so in this lecture video, I will be discussing with you how to calculate the electric field of a dipole. Okay, so so far, let me share my screen first. Yeah. So at this point in time, I would like to assume that you have read about electric field. You have studied the lecture videos on how to determine electric field. So in this at this point in time, we will try to explore our understanding to broaden our understanding of electric field. We know as for now what the source of electric field is. So meaning I hope by now you already know the source of electric field. So of course, it is any particle which has a net charge. So when I say a particle, I'm talking about a point charge. And when we speak of a point charge, it's a charge body whose radius is much smaller compared to the distance where you are calculating the uh, where it is interacting with another point charge. Okay, so we'll be focusing our attention now on electric field of a dipole. Okay, so a dipole, from if you dissect, I mean the term di means two, and then polar, it talks about two equal magnitude but opposite sign. Okay, ayan. So it's just it is a physical entity, kumbaga, pwedeng ganun, which is composed of two opposite charges. So when you speak of opposite charges, it means that the magnitude, so if we have the magnitude of the positive charge is equal to the magnitude of the negative charge. And then they are separated by a small distance. So that's the definition of a dipole. So we have two kinds of dipole. If you have read our textbook, we have the permanent dipole. Okay. So an example of a permanent dipole is the water molecule. Okay. So in a permanent dipole, there is always this constant separation of the two equal and opposite charges. No? There's a mechanism or an interaction that keeps the two the distance the separation constant. So for example nga is the water molecule. Another one, we can also have an induced dipole. So kung si permanent dipole, this is natural. No? It is really found in nature na. Pero induced dipole, from the word induced, you are somehow trying to defy what's natural, no? Parang pinilit mo, okay, something like that. But you have to do something. So an induced dipole is due to the polarization of an object, no? An insulator, for example, or pwede ring conductor. So in an induced dipole, say for example, you have a sphere, okay, and then initially it is neutral. So I'll draw here equal number of positive and negative. Neutral pa siya. Okay. Now, um, we can make this, we can subject this to an external electric field, and then the charges here will rearrange such that it undergoes polarization. Okay. Ayan. So when we speak of polarization, this is only, of course, for, let's say, insulators. In an insulator, the electrons are not free to escape the atom, no? So, however, insulators can be charged by polarization. So, how does polarization happen? You have an insulator and then you put it in a space where there is electric field. The electric field now, I mean the charges now will tend to be rearranged. So the rearrangement of the charges as they react to the presence of an electric field, that's what we call polarization. But we also have a different meaning of polarization when it comes to light. That's a different meaning, no? I don't know why they keep on using this term for several meanings. So if there is an existing electric field, for example, let's say we have a parallel plate capacitor, let's just say, so this is the positive plate, and this one's the negative plate. If we put now our neutral particle here, then we know that the electric field goes from positive towards negative. So if I will draw the electric field here, we will learn later why the electric field is parallel here, no, and equidistant. So this is now the electric field lines, the red lines of our parallel plate, oppositely charged parallel plate, which we'll call capacitor. So the portion here, which is near the positive, will somehow attract the negative charges of the sphere. So there will be a rearrangement of the sphere. This part, the left part now, becomes somewhat negatively charged, and this one becomes positively charged. So these two, the net Q here, the net negative charge and the net positive charge here, they're both equal, and there's somehow a small separation here between them. So the sphere now is said to be an induced dipole. Okay? So the rearrangement of the electric charges within the insulator as we place it in a space where there's electric field, that's the process we call polarization. But again, light polarization is also different, no? The one that we have, for example, in 3D glasses, no? If you cannot view 3D movies if you do not have the polarized glasses. So that polarization is different from the polarization that I'm talking about here. Okay? Ayan, medyo mahaba na. Now, so let's continue. So that's what we call dipole, no? So regardless whether it's a permanent dipole or an induced dipole, the equation that we will be deriving now uh, will be applicable. But of course, there is always this range of validity, no? So we will only focus for the physics for ECE, the undergraduate physics. We will only focus on simplified cases, no, very idealized cases. So what I mean about that is this: for the electric field of a dipole, remember kasi class, you can always calculate the electric field of a certain charge at any point of evaluation that you'd like. So meaning there's infinite number of points around a charge. There's also infinite values of electric field. So itong sa atin, we will only focus on how to calculate the electric field. Oops, I lost control of my pen. Oops. Yan. The electric field of a dipole on a point along its axis. Ayan. So this is a simplified case, no? A very special case. In other words, whatever equation that we will be arriving at, remember that you can only use this for this case only, no? Where the point of evaluation is along the axis of your dipole. So electric field of a dipole on a point along the axis of a dipole. Ayan. Okay. So the final equation na dapat ma-solve natin, we have here the electric field of a dipole. Okay. On axis ito, you have 1 over 4 pi epsilon naught. Let me look at my código. And then you have 2qs over r cubed. So this is the equation that we'd like to derive. Yan. And you can only use this. This will give you the magnitude, right? This will give you the magnitude only. So I'd have to put here the magnitude. And then the direction will still be either up or down, left or right, or a certain angle. No? So the direction will depend on, will have to be determined depending on the, uh, depending on the location of the point of evaluation. Yan, that's for the direction. So let's continue. Okay. So say for example, I just follow the, pwede kasing ilagay ko yung dipole sa x-axis, pwedeng sa y, no? But let's say I choose it to be along the y. So I have my dipole here, positive. This is my positive charge. Small separation. It's my negative q. So let's define some terms. The separation between the two opposite charges, let's call it S. Okay. And then let's put this dipole along the y-axis. With the center at the x. Okay, but I don't want x muna, si y-axis lang muna tayo. So let's say we want to determine the electric field of this dipole at this point, at point P. So what is the electric field of the dipole at P? Yan. Okay. First, we will apply the principles that we learned about electric field of a point charge, because these are two opposite point charges. Okay? So let's determine, step one, let's determine the direction muna of the individual field, and then we will add them, diba? So basically, we will be using the concepts we learned about the magnitude of the field as k q over r squared. And then we also have the concept of superposition. Superposition of electric field. So yan ang gagamitin natin, itong dalawa. Okay? Now, so at point P, the electric field due to the positive charge will be away from the source. Tama ba? Okay? So we'd say that at this point here, the electric field due to positive charge is upward. So I label this as the electric field of the positive charge. Okay. What about the electric field contribution of the negative charge at point P? So this is negative. At any point surrounding the negative charge, the electric field will always go towards it. Now, if you look at this, the positive charge is closer to the point of evaluation than the negative charge. Okay? So remember, the inverse square relationship between field strength and the separation between the source charge and the point of evaluation. So ito siya, this will be downward, but I have to draw this na shorter because it's really obvious that the electric field of the negative charge at point P is really weaker than the electric field due to positive charge at point P because of the value of their R. So this short downward arrow, I will label this as the electric field due to the negative charge. Then, we will apply superposition. At this point, we have two electric fields to be added as vectors. So, magve-vector sum tayo dito, kaya superposition. So, with that, it's very obvious here that the electric field of our dipole is one-dimensional. Why? Because it's just along the y-axis. It has no x component. So, along y-axis only. Okay? It makes our work easier kasi one-dimensional. Okay. Next, we will add these two vectorially using superposition. So, I will have to say here that the summation of the electric field at point P, so I'll just say it's dipole, point P na lang muna. Sorry. Summation of the electric field at point P is the vector sum of positive electric field due to the positive Q plus a negative electric field due to the negative Q. So this is already vector sum, applying the superposition. No? Meaning, yung direction is already given by the positive and negative here. But once you put the magnitude, remember this is absolute value yung charge. Kasi yung direction, andito na nilagay natin sa labas, whether it's up or down. Okay? Now, we will put now the definition of electric field. But this time, I want us to get used to using another value of K, which is 1 over 4 pi epsilon sub naught. And then you have Q over R squared. So let's use that instead of K. Okay? Yan. Why? Because this is in preparation to in preparation for calculating the electric field due to continuous charge distribution. That will be in another lecture. So positive electric field, this will be positive 1, 4 pi epsilon sub naught. And then I have here the absolute value of Q plus over the distance between plus and P. So I'll use R positive here as the distance between positive Q and P, and then square it, okay? And then minus, I have 1 over 4 pi. This is now for negative electric field. And then I'll have the magnitude of negative Q over the distance between point P and negative Q. That's the definition of R. So do not be confused, ha? Ang R dito sa definition ng electric field, this is the distance between the source charge and the point of evaluation, kung saan ka nagsusolve ng electric field. Do not forget that, okay? Para hindi kayo ma-confused, okay? Now, let's define now the values of R positive and R negative, okay? Think, bearing in mind their description. So, we say that, before I forget, si point P here, from the origin, is at a y distance away from the origin. Ayan. So, from here to point P, it's y. Okay? And then, another thing, we place the dipole such that the midpoint is at the origin, no? For simple calculation. So we'd say that from from the center of the positive charge up to here, this would be 1/2 of S because S is the distance between the two. So I label this as S, 1/2 of S. The same thing here, from this bisector going here, this is also 1/2 of S. So that when you add the two, it's really one whole na S. Okay? Now, what is my R therefore in terms of Y and S? So this is P. Si R positive ngayon, class, will be from this point to this point only. So this is now R positive because the R in this equation of E is the distance between the source and the point of evaluation. So if we have to write an expression equivalent to R in terms of Y and S. So if you agree, itong si R is obviously Y minus S over 2. So I'll write here R in terms of Y. It's just Y minus S over 2. That's R positive. Okay. What about R negative? So the R negative is from this point of evaluation going down here to the source charge negative. This is now my R negative, which is obviously it would be the green arrow Y plus S over 2. So si R ngayon is Y plus S over 2. Ayan. So, yun yung difference nila ni R positive at saka ni R negative. So, Itong values ngayon ni R in terms of Y and S, we will substitute it here so that our final answer would be in terms of S and Y. Kasi si Y mamaya magiging R na yan. Okay? Sige. Ito pala, this is for Y at large distance. So much greater than the separation. Take note of this. Okay. Let's continue. So let's apply na everything we learned about algebra here. We can factor out Q because we say that, oops, ano na yan? So we say that the magnitude of Q positive equals the magnitude of Q negative. We can simply call it as Q. So you can factor out 1 over 4 pi and Q. So lagay ko na lang sa taas dito si Q. We are now factoring common terms over 4 pi epsilon sub naught. So the remaining here for the first term would be 1 over R positive squared minus 1 over R negative squared. Okay, let me move this. Now we will substitute the values of R in terms of Y. So we have Q over 4 pi epsilon sub naught 1 over, I'll put R positive, it's Y. I hope I'm not overlooking something. S minus, then square it, minus 1. And then R negative is Y plus S over 2. Yan. And then algebra takes over. So help me. And then if you see any mistake in the derivation, malalaman naman natin, no? Kasi hindi natin, I will not be arriving in the box value here. So we'll see. Okay, let's continue. Move it there. Okay. Now let algebra, this is subtraction of rational expressions. So we will do, these are dissimilar fractions, kumbaga. So we learned in our elementary math that if we subtract dissimilar fractions, we get the LCD, right? So the LCD here is just the 2, product of the 2. So I'll just copy this, S2 squared times Y plus S over 2 squared. Ayan. So LCD divided by the original here, this cancels this and that. And then we have Y plus S times 1. So it's just Y plus S over 2 squared. Minus, itong kabila, ito na namang si plus ang magka-cancel. Ito na lang si Y minus ang matitira. Y minus S over 2 squared. Ayan. If you see, there is special product here that is appearing, no? I hope you can see the difference of 2 squares. So, if you recall, difference of 2 squares, paano i-factor? So, we say that the difference of 2 squares, if we factor it out, factored form, the partner of the difference of 2 squares is product of sum and difference, di ba? So we get the square root of the 2 and then A minus B. So this is the product of a sum and difference. Product of a sum, these are special products. Sum and difference. And then the partner is difference between 2 squares. 2 perfect squares. So following this, we can show the factored form of the numerator. So we have Q 4 pi epsilon sub naught. Yan. Our A becomes Y plus S over 2 and our B becomes Y minus S over 2. Ano na? What is that? Wala. Asan pala si Dada? Okay, asan na ako? So we have here, y plus... Gabi, go back to your class. Sagdi na. Hayaan mo yan. Si Dada na, ana. Y plus 2. So, nako. Ay, nako. Ang gulo dito. Okay. So, this is y. And then, we have plus y minus s over 2. Yan. So, this takes care of the a plus b. And then, times, you have y plus s over 2 minus y minus s over 2. All over y minus s2 squared, y plus s2 squared. Bracket na siguro ito, curly brace na yan. Okay? And then we can simplify the numerator sa taas. Of course, numerator sa taas. So we have q over 4 pi epsilon sub naught. Let's look at the top. So y, this is y plus y. It becomes 2y. Okay, 2y. And then s half plus this is 0. Okay, plus 0. And then sa kabila, y minus y becomes 0. And then s plus this becomes s half plus s half equals s. So this becomes plus s over, we have y minus s over 2 squared, y plus s over 2 squared. Yan. So that this now becomes 2ys. So this becomes 2qys over, I'm sorry. Let's write it muna in a way na separate C. We have 1 over 4 pi for the constant. And then we have 2 times q times y times s all over y minus s2 squared, y plus s2 squared. Ayan. Now, in reality, we can only, in reality, the electric field of a dipole can only be sensed when y is much greater than the s, meaning at the point farther from the dipole. So we will use that limitation where y is much greater than s, such that with this limit, the denominator now is reduced to, so pag itong masyadong maliit si s compared to y, this can literally be negligible. So let's take it out. And then this will now become 1 over 4 pi epsilon sub naught 2qys over, you have y squared times y squared. Okay, so it becomes y to the 4th, such that this gets cancelled and then this becomes 3. So therefore, the electric field, this is still the magnitude, no? Okay. The electric field magnitude is of the dipole is 4 pi epsilon sub naught, and then you have 2qs over y cubed. But at this point where y is much larger than s, then we will replace y will be replaced with r. But the r is the distance between, take note, only for dipole, distance between the center of the dipole and the point of evaluation. And the point of evaluation. Such that, okay, so this now becomes the electric field magnitude of a dipole for this condition is equivalent to 1 over 4 pi epsilon sub naught to QS. There's still the separation distance there over R cubed. So this gives you the magnitude. And then the direction will just depend on whether Y is nasa taas or nasa baba. Basta it's always along the axis. Okay? So for this particular case, this is now the magnitude. We're able to 2QS cube. Are we able to derive the correct answer? Ayan. So we have here the dipole magnitude for on-axis value, where Y is much greater than S. So for this particular example, if Y is very much larger than S, if we can draw this again to, to have a picture of the R, okay, it's very important. Oh. R is the distance between the center of the dipole and the point of evaluation. So if we have a dipole, ulitin natin ha, for this particular case. This is my plus and this is my minus. Positive Q, negative Q. Along the axis. Ayan, this is the center of mass of the dipole. So is Y. So if this is point P, then the R is from the center of the dipole to the point of evaluation. So this is the R that you will be using. Where Y here, let's say Y, so from here to the center, Y is much greater than S. Okay? So in this particular case, the direction, you'd say that, so parang ganun pa rin sa first example natin, this is E positive, this is E negative. So that we say that the electric field of our dipole, if we include the direction now, it will be 1 over 4 pi 2QS over R cube. Cube na yan, ha? And then the direction here is, mas malaki si plus kaysa kay minus. So you'd say positive J hat. Ayan. So this now includes the magnitude and the direction. But if the dipole is placed along the x-axis, so we have, let's say this is positive Q and this is negative Q. They're now in the x-axis. So this equation can still be used if the point of evaluation is along the x-axis. So say for example, if you are to determine the electric field here at point P, okay, because of the dipole, if you know the separation S, so the R would be from the center of mass of the dipole going to the point of evaluation, that is your R. Okay? And then for the direction now, the P positive is going to the right. This is E plus. And the negative charge now is closer to the point of evaluation. So siya ngayon ang mas malakas. So we'll draw here a longer arrow for E negative so that you know that the electric field direction of the dipole is obviously towards negative I hat. And then the magnitude is 1 over 4 pi 2 QSR. So you need to determine what's the magnitude of Q, what's the separation, so that you can get. So that's the limitation of this one, of this equation. And we'll only focus on idealized cases such as this. That's the level of the college physics, no, for you. Ayan. Okay? Now, finally, itong si value na Q times S, charge times separation, this is for dipole only ha. So charge times separation class is given another term because it's also another physical quantity and we call it the dipole moment. Buti pa itong dipole may moment. And the symbol is like momentum symbol that we use in physics 1. Okay? Pero this has nothing to do with momentum na mass times velocity ha kasi hindi naman nagmo-move ang charges natin. We're still in the study of electrostatics. I do not know the history bakit tinawag siyang dipole moment. But anyway, that is the another physical quantity, no? Which is just, so if we get the magnitude of the dipole moment, it's the magnitude of the charge of the dipole times the separation. So our unit would be coulomb times meter. Ayan. And then the direction, since this is a vector quantity, so this is the magnitude. And then the direction is, it's always drawn from the negative charge to the positive charge. Along the axis pa rin, to the positive charge. So in this, say for example, we have this dipole here in the x-axis. So if we know the Q and the separation, you get the dipole moment magnitude, and then the direction is along the axis, and then it's going from negative going positive. That's the dipole moment. So in terms of dipole moment, the equation will become, so when if dipole moment ang binigay sa inyo, then this equation, the electric field of the dipole, still along axis ha, along the axis where y is much greater than s. Do not forget that. Tapos on axis. If the problem does not say anything about this, then do not ever dare using this equation. Ha? This is only for dipoles, and then the point of evaluation is along the axis where y is much greater than s. Sasabihin naman yan. Okay? So electric field of the dipole becomes 1 over 4 pi epsilon sub naught, and then you have 2 times dipole moment over r cubed. Ayan. Where, so whatever is the direction of the electric field, that is also the direction of the dipole moment. Kung titingnan nyo dito, the electric field is towards negative x, so si dipole moment papunta din doon sa negative x. So that's one thing. And then, of course, itong si 1 over 4 pi, we can also replace this with k. Kaya lang sabi ko nga, for this, the reason why I'm using this now is because we'll be using this again when we when we do electric field calculation for charge distribution. Okay, I think this has been quite long, so I will end here and then until the next video. Okay.